Assalamualaikum and good afternoon to all my friends. We're from group the fourth want to present our circuit that have been proved by our lecture. So this is our circuit. We have 4 resistor, 1 inductor and 1 capacitor and 1 source. So from here we change the frequency to the time domain. So from this source, et 5 sine 2t, we change them into time domain. So this is, we have a formula, sine omega t is equal to omega s squared plus omega squared. So this is the formula. So from here, 5 sine 2t, we convert them into like this, 5 2 over s squared plus 2 squared. So from here we've got 10 s squared plus 4 s squared plus 4. So the resistance is still the same, 5 5 5 5. Inductor we change them into 2s, and capacitor we change them into 2 over s. We want to find our V1, so from here we do nodal analysis. So V1 minus 10 over s squared plus 4 over 5 plus V1 minus V2 over 5, this V1 minus V2 over 5 plus V1 over 5. So from here we arrange this thing into like this, and we just calculate like usual, calculate, and we've got this thing. From here we can do, so to find V1 we're using nodal analysis to search for V1. So V1 minus 10 over s squared plus 4 over 5 equal to V1 minus V2 over 5 plus, it's not equal, it's plus V1 over V2 over 5 plus V1 over 5 equal to 0. So from here we've got one equation. So after that we calculate until we got one equation for V1. V1 equal to 1 over 3 V2 plus 10 over 3s squared plus 2 for V1. This is one equation. So after that we search for V2. V2 we've got like this, V2 minus V1, V2 minus V1 over 5 plus V2 over 2s plus V2 over 5 plus 2s from here. V2 minus V1 over 5 plus V2 over 2s plus V2 over 5 plus 2s equal to 0. So we've got here, so after we got this equation, we calculate as usual until we get this equation for V2. So this equation for V2, so this is the second equation. From here we've got 3 partial fraction here, a, b and cs plus d, because we have s squared plus 4. So from here we arrange first the partial fraction, our partial fraction we arrange first, and then we insert our s. So we've got s minus 0.53 because here, and s equal to negative 1.13 because of here. So after we insert, we've got value of a and value of b. So here, after that, we want to search our cs plus d, but we cannot, we don't know how to search the cs plus d, so we using comparison of coefficient. We arrange again our partial fraction here. So we arrange, this is where we got from here. From here, we arrange again, and we've got like this. So after we arrange, we've got like this. We're using a comparison of coefficient. So we've got here. So we compare our coefficient. So for s squared is here. Here. So s squared. So s squared we've got here 1.13a plus 0.53b plus 1.66c plus d equal to 1. So we compare, we've got this equation, so we made it as 1. So after that, we compare our coefficient s. For the coefficient s, we compare this 4a plus 4b plus 0.6c plus 1.66d equal to 0.4. So here we've got the equation. So here, so we calculate this until we've got this equation 0.6d plus 1.66d equal to 1.3. So this is a two equation. So after that, we compare again our coefficient as power of 0. So we compare, we've get here and equal to 0. So we've got d equal to 0.7. So after that, we insert our d into equation 2. Also, we can insert in equation 1, either of them we can insert. So I choose to insert in equation 1. So I insert this thing, 1.66c plus 0.7 equal to 1.1. So we've got c equal to 0.24. So our final equation is, so we've got this final equation. And then from here, we change them into frequency. So we've got V2 equal to this millivolt. So how we want to get V1 is, we just input our V2 into our first equation. For V1 here, we input this V2 in here, this first equation V1. So we've got this millivolt.
Okay, next, after looking for V1 and V2, we continue looking for IT, I1, I2, and I3. For IT, equation for IT is V1 minus 10 over S squared plus 4 over 5. We get this equation from node 1, which is this, V1 minus 10 over S squared plus 4 over 5. So just doing the usual calculation, we get IT equal to this in milliampere. It goes same to I1 and I2 using equation from node 1. Okay, for I3, we're using partial fraction. This is the equation A, B, and C. So for A, this is the equation. So doing the usual calculation until we get this answer, same as B, and this is the answer. For C, using comparison of coefficient, we get this equation. And then for S power 1, we get answer for C equal to 0. For S power of 2, we get B equal to minus 0.09, and this is the final answer, 0.09 over S minus 0.09 S over S squared plus 4. After we got the answer for I3, we change the answer from Laplace time domain to frequency domain, and this is the final answer in milliampere.
This is an I4. To find the value of I4, we need V2 divided by 5 plus 2 over S, which is the value of resistance plus inductance. This value move to the left hand side, then only V2 remain on the right hand side. Then we insert the value of V2, which is these four values. This is the calculation of I4. After that, we get the answer of I4. The answer is divided into four parts, which is part A, B, C, and D. The first part is part A. As for this part, we assume S equal to 0.53. Then we get the value of V is 0.02. Then we assume S equal to negative 2 over 5. Then we get the value of A is negative 0.09. Hence, the answer is 0.09 over 5S plus 2 plus 0.02 over S plus 0.53. The second part is part B. To find the value of B, we assume that S equal to negative 1.13. Then we get the value of B is equal 0.08. To find the value of A, we assume that S equal to negative 2 over 5. Then we get the value of A is equal negative 1.51. Hence, the answer for B is negative 1.51 over 5S plus 2 plus 0.08 over S plus 1.13.
As for part C of I4, first you need to assume S equal to negative 2 over 5. Hence, we get the answer for A equal to 9.23 milli. After that, we use the coefficient method so that we can find the value of B and C. First, we use the variable of S2. Hence, we get the answer for B. Next, we use the variable for S is then we get the answer for C. So the final answer is This is the answer for part C. As for part D, we assume S equal to negative 2 over 5 to find the value of A, which is A equal to negative 0.07. Then we use the coefficient method to find the value of B and C. First, we use the variable of S2 to find the value of B. Hence, this is the value of B. Then, the variable for S is to find the value of C. Then, the final answer is this is the final answer for part D. For the final value of I4, insert all the values that we have calculated before. And then this is the final answer for I4. Then we calculate, we get then this is the final value for the frequency domain. Then we transform the value from frequency domain to time domain. Then we get the final value of this is the final value in milliampere. hence this is the final value of I4 in milliampere. Thank you.